distance of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. You're lost on an alien planet. Food is running low. Oxygen is running out. Help is 100 million miles away.
Mars, it's a lethal place.
Where can you hide from blasts of space radiation?
Charged particles would be hitting any astronauts that we had on the surface. They would not be protected.
How can you stand up to a deadly dust storm?
The dust on Mars could eat away at the fabric of the spacesuit. That would be catastrophic.
What will you do when you run out of air?
You will die a horrible death.
How can you survive crash landing on Mars? Humans crash landing on Mars. Struggling to survive on a hostile world. It's been a favorite theme of science fiction movies. They got a lot of things wrong. But NASA and other space agencies are planning to send people to the Red Planet in the next few decades. So the questions of crash landing and survival have to be taken seriously.
Well, think about what you're trying to do. You're sending a mission to Mars, you're sending it to an unknown location with an unknown environment. All it takes is one thing to go wrong, then you've lost the whole mission.
This program, based on recent scientific information, presents one possible scenario of what might happen in the near future. Imagine an international crew has been selected to explore Mars and set the stage for a permanent base. In old movies, such crews were brave, skilled, and resourceful. Well, the movies got that part right.
The bottom line is that when you're dealing with a small group of individuals forming a crew, not a large community, but a small group of people, the specific individuals that you end up selecting is really very important. Who would you send to Mars? Not jacks of all trades who are aces at none. You want aces at many trades on your crew.
The most important skill among the crew is that of mechanic. I would have 2 of the 4 members of the crew selected primarily for their ability to fix things. After mechanic, the most important skill among the crew is that of field scientist. People that are qualified to follow hits in the geology to find fossils or to find places where we could drill for water. Okay, in Star Trek terminology, 2 Scotties and 2 Spocks.
But here's something old movies got wrong. The idea that humans will fly to Mars in a single needle-nosed spaceship.
Unlike the case in many old science fiction movies, it's actually cheaper and more efficient to send a bunch of material to Mars on different rocket ships. If you try to put them on one rocket ship, it turns out that that ship has to be enormous and probably nuclear powered, and there's all sorts of dangers and problems associated with that.
In most real-life scenarios, the Mars astronauts will land and leave in separate crafts. The Habitat Module, or HAB, will be their home during their 18-month mission on the Martian surface. They'll take long-range trips in a pressurized rover packed along with them on the HAB. A smaller rover for shorter trips has been pre-positioned at the landing site, along with the astronauts' ride home, the Earth Return Vehicle, or ERV. The ERV isn't just waiting for the astronauts. It's transforming Martian resources into rocket fuel and breathable air.
The Earth Return Vehicle runs a pump which sucks in the Martian air, which is 95% carbon dioxide gas. And we can react that carbon dioxide gas with a small amount of hydrogen that we brought from Earth to produce a large supply of methane, fuel, and oxygen. A crew of 4 astronauts land on Mars near the Earth return vehicle. They use their habitat as their laboratory, as their exploration base, but when they're done, they get in the Earth return vehicle and they fly back to Earth. They leave the hab behind on Mars, so each time we do this, we add another hab to the base, and before you know it, we've got the beginning of the first human settlement on a new world.
So where should we land on Mars? Well, Mars is a fascinating planet. There's a lot of interesting areas. It might be better initially to choose a region near the equator, especially a flat area, but also near geologically interesting features.
One thing that mustn't go wrong is the HAB's landing technique, called aerobraking.
Aerobraking is the art of using the friction of the Martian atmosphere to slow down a spacecraft.
Imagine this ball is the habitat module entering the Martian atmosphere. The pole is Mars, a very skinny Mars. Now, I could use rockets to gently slow this thing down and land at the desired spot where this duct tape is. But that would require a lot of energy, which requires fuel, and that's heavy and expensive. Instead, we could let the Martian atmosphere slow the HAB down. See that? It's gently slowing down. And only near the very end, when it's getting very close to the surface, would we turn on some retro rockets and use a balloon parachute called a balloon to bring it to the desired location, like that. Now, the danger is that if the angle of entry is wrong or the speed is too fast, then in fact friction can overwhelm the heat shield, the aeroshell, and the HAB can burn up like a meteor in a Martian atmosphere. And even a slight miscalculation can lead to a landing that's too rough or in the wrong place.
There's about 1,000 things that have to happen. You come in on a heat shield, you're going quite fast. You use the friction of the atmosphere to help slow you down the heat shield. The heat shield needs to be jettisoned. You need to aerobrake through the atmosphere as much as you can. You need to pop out a parachute to slow yourself down. You probably then need retro rockets at the bottom. You need to cut the parachute and get it away from you. This is extremely difficult, among the most difficult things there is to do.
Then, a few miles above the surface, something goes very wrong. The HAB hurtles into a Martian dust devil of terrifying proportions.
Dust devils on Mars are vortices in the atmosphere, so rapidly spinning columns of air that lift dust off of the surface and loft them into the atmosphere. Now, on Earth, dust devils may only be a few hundred feet high. But on Mars, they can be 3 to 4 miles high, so they're simply immense structures.
The dust devil engulfs the HAB, throwing it dangerously off course. Tracking stations from Texas to Kazakhstan are following the descent. But Mars is so far away, it takes 18 minutes for the HAB's transmissions to reach Earth. When the signal comes through that the HAB is headed for a crash landing, the astronauts have already crashed. But where? And are they alive or dead?
There's only one thing you can do at launch, and there's only one thing you can do at landing, and that's pray.
Somewhere on Mars, the astronauts are alive, but communications are out. They can't talk to Earth. Worse, the dust devil has taken them far off course.
When humans first land on Mars, it'll be a truly magnificent event, one of the most historic events ever. But you know, our astronauts crash landed, so they're going to step out, not knowing where they are, what's going on.
The sun would be about half as bright as it is here. The intensity of sunlight at the Martian equator is about the same as that in Norway on Earth or Alaska.
In shadow, everything on Mars would have this kind of yellowish-brown, reddish hue. And only things in direct sunlight would show their more true color. And that's because the light is being bounced around amongst all these reddish dust particles.
It'll be a wondrous scene, but they won't have much time to enjoy it because they need to figure out where they are, how to get themselves to safety, and what to do.
How do you find out where you are on Mars without instruments? These 21st century astronauts fall back on an ancient technique: celestial navigation.
The Martian moons, Phobos and Deimos, they're both in equatorial orbits. The point at which they rise, that would be due east. The point at which they set would be due west. At their zenith, to the extent they deviated from being directly overhead, that would tell you how far you were from the equator. The time of rise and set, if you compare that to an almanac, which you might have in your computer, would tell you your longitude.
The results are shocking. They have crashed in the eastern half of the largest canyon in the solar system. Discovered in 1971 by the Mariner 9 probe and named for it, the Valles Marineris is just south of the Martian equator, several times as deep as the Grand Canyon, and as long as the continental United States. The astronauts are hundreds of miles from the Earth return vehicle. And there's worse news. The damaged hab is leaking oxygen at a critical rate. It can't be repaired. The crew could be dead within days. It's a near-future scenario that might happen. The first humans on Mars are hundreds of miles off course, stranded deep in the gigantic Valles Marineris. They can't communicate with Earth, and their damaged habitat module is leaking air. Almost every Mars movie imagines a breathable atmosphere in at least one section of Mars so the actors can take off their helmets. But in fact, Mars' atmosphere is 95% carbon dioxide and as thin as Earth's atmosphere at 100,000 feet.
I'm often surprised by how caught up we can be by sort of this romantic vision of Mars. It looks like Utah or California here. But the truth is it's a lethal place.
The astronauts have one chance, and they take it. They assemble the rover, which has a 3-week air supply.
A pressurized rover is sort of your RV. You are living inside the rover. It's pressurized. You're in shirt sleeves. You don't have to be wearing a spacesuit while you're driving it or living or working inside.
The rover is functional, and so is its communication system. The astronauts radio home that they're alive.
If some component or something goes wrong on it, there's a backup that wouldn't lose the mission. So redundancy can be a very good thing, or at least the ability to design for a failure, if you will.
But the conversations are not like the constant back and forth of the Apollo moon missions.
Imagine this ball represents a message, a conversation between an astronaut on the moon, me, and Mission Control in Houston, Texas. Now, I'm standing a few inches away from Houston, but in reality, the moon is 240,000 miles away. Now, radio waves travel at the speed of light, 186,000 miles per second. So it's only about 3 seconds between "how are you" and "I'm fine." Pretty easy to hold a conversation. But Mars is, at minimum, about 150 times farther away than the moon. So I have to go all the way over to here. We can still communicate, but there's a longer delay. In reality, The distance between Earth and Mars is between 35 million and 240 million miles. So the time lag between how are you and I'm fine can be between about 6 and 44 minutes. That's for a complete exchange. So if there's an emergency, it can't be dealt with in real time. But there's a bigger problem. Like visible light, radio waves travel only in a straight line. And both Earth and Mars rotate on their axes. So there are times when people on the two planets can't communicate with each other. We can solve this with two properly positioned satellites. If there's a satellite orbiting Mars, a message can be sent from Mars to Mission Control in Houston. It gets sent to the satellite orbiting Mars, then to the Earth orbiting satellite, then to Mission Control, and back again. Now, there's still a time delay of up to 44 minutes between question and answer, but at least the Mars astronaut and Mission Control can formulate a survival plan.
Working through the communication lag, the plan takes shape. Load the fuel cell-powered rover with food and equipment and drive it east to where the Valles Marineris empties into an outflow valley, probably carved out billions of years ago when Mars had a thicker atmosphere and liquid water still flowed on its surface. From this exit point, it's less than a day's drive to the Earth return vehicle at the original landing site.
So you can imagine having a desperate trip across the Martian landscape to get back to the return vehicle and perhaps do a little bit of scientific research, but most importantly, save yourself and get back to Earth.
Everything depends on some very cold equations. Each astronaut has a daily need for 3 gallons of water, 2,000 calories of food, and 2 pounds of oxygen. Survival technology can help. They can extract water from Mars itself, using equipment on board the rover.
The Mars Odyssey spacecraft has shown that average Martian dirt in the equatorial regions is 6% water by weight. So if you want to get water out of that, you can just take some of it and throw it into a pot like a pressure cooker with a lid and heat it to 150 centigrade, and you get out the water. And if you put in about 2 gallons of dirt, you'll get out about a pint of water.
But other human needs are not so easily supplied on Mars.
Certainly on a 2-week journey, if you had to make it across the desolate Martian landscape, you could cut down on food. You could have starvation rations. You can even cut down on water. But the one thing that you absolutely need, minute by minute, is air. You have no flexibility in the amount of air that you need to make it for a specific amount of time.
Despite the need to get to the ERV, there is enough air for several brief EVAs, or extravehicular activities.
Part of the reason for sending people to Mars would be to do some compelling science. So we would imagine them taking samples, analyzing them, trying to understand the environment when those rocks form, things like that. Astronauts could use a whole variety of tools, hammers, hand lenses, spectrometers of various sorts, chemical analysis machines. There'd be probably some mobile laboratory on the rover that would use the materials that they gathered to look at the composition and so on.
There's a number of theories as to how the Valles Marineris was created. It's still not fully clear how the structure came to be, but in most likelihood, quite a few processes were involved. I think that being on the ground and doing field geology is essential to really understanding the processes that have sculpted a complex landform like the Valles Marineris. It's not a simple story. It wasn't just a crack in the earth. It wasn't just fluid flow that formed that. There were different processes acting at different times, layering on top of each other, forming a complex book. And in order to read that book, you really need to be there to turn the pages.
Valles Marineris has a whole variety of different segments. There's places in the middle where there's 1, 2, 3, or even 4 parallel canyons where you go down and up and down and up and down and up. And then at the very eastern end, it looks like water came flushing out through what would be a chaos zone, catastrophic floods of water that might have come out.
Was there life in that water? Could some of the rock samples they dig up have enough evidence of fossilized bacteria?
Mars was once a warm and wet planet, and we know that for a fact because there are water erosion features all over the surface of Mars. To look for fossils of life, you want to look for places where water has flown or accumulated, and the Valles Marineris might be one of those places.
Is it even possible that they will find evidence of liquid water under the surface? And in that water, living organisms?
Will life form anywhere that liquid water is stable? Or is there a 1 in a trillion chance occurrence that leads to life? Was there a second Genesis on Mars?
I think it's certainly possible that there's bacterial activity on Mars now, but that's by no means certain. It's a very interesting current scientific question. I think it's one of the sort of most intriguing questions in solar system science.
Suddenly, the search for life pauses as the fight for survival resumes. Mission Control signals that a high-risk solar flare is headed for Mars.
A solar flare is a tremendous outburst from a relatively small region of the sun. A huge amount of energy goes pouring out explosively, and a bunch of energetic charged particles go zooming through the solar system. They can interact with cells and harm them. Also, high-energy electromagnetic radiation, like X-rays, gets produced, and those can harm us as well. So it's wham, and then wham again sometime later.
Earth's magnetic field shields us from the worst effects of solar flares. But Mars lost its magnetic field 4 billion years ago.
After a solar flare is seen by people on Earth, we want to warn the astronauts on Mars. Now, we can't warn them about the electromagnetic flash because our warning signal would travel at the same speed as that flash from the sun. But we can warn them about the onslaught of charged particles. The high-energy charged particles can travel perhaps at half the speed of light.
The HAB has a radiation-proof chamber, but it's now too far away. While the astronaut spacesuits shielded them from the solar flare's X-rays, they have only minutes to seek shelter before the flare's high-energy second wave slams into Mars. If a future human mission to Mars crash lands, the astronauts will have to contend with even more than the harsh Martian landscape. A solar flare of charged protons would be far more dangerous here than on Earth.
Well, Mars doesn't have a magnetic field like the Earth does, so all of these high energetic particles and these charged particles would be hitting the surface directly and hitting any astronauts that we had on the surface. They would not be protected from all of these dangerous rays and these dangerous particles, whereas on Earth, we're comfortably protected by our magnetic field. There are a number of bad effects that would come about from the energetic particles hitting an astronaut on the surface. Increased rates of cancer, for example, or other diseases, radiation sickness and radiation poisoning.
In fact, astronauts aboard the space station have occasionally been told to hide in special chambers that protect them against the charged particles and radiation coming from a solar flare.
For the astronauts in the middle of the Valles Marineris, the only shelter is their pressurized rover. The rover's primary radiation shielding isn't lead, it's the food packets lining the walls, along with the astronauts' own waste material.
Feces contain hydrocarbons, and hydrocarbons contain hydrogen, and hydrogen is a very good absorber of radiation. Hydrogen that you have in the form of food before it's consumed will help shield you from some portion of this radiation, and certainly once you've consumed the food, you want to put your feces in these little sealable Ziplocs and back on the wall of your vehicle to shield you from radiation.
If you're going to survive in space, almost nothing can go to waste. Not even waste. With the immediate crisis over, the journey to the Earth return vehicle continues. Then, something unexpected happens. The astronauts take a vote and change the plan. Rather than using the ERV to fly home 500 days ahead of schedule, they will stay and complete the mission.
The team back at Johnson Space Center is going to have much less knowledge of the circumstances of the crew and the real options open to them than the crew themselves have. So I think that a Mars mission is going to have to be commanded from the front, and that rather than having a mission control, we need to have a mission support.
The astronauts' new plan is to make it to the Earth return vehicle and use it in place of the HAB as their base of operations.
It's much smaller than the HAB, but it has a power supply and has the ability to make extra oxygen. So the crew could, in fact, go to the Earth return vehicle and live in it and work out of it.
The astronauts' confidence in their survival shoots up as they reach the outflow channel at the eastern edge of Valles Marineris. There's enough food, water, and air to make an easy drive to the ERV. Then, an astronaut sees something unusual. An exposed layer of rock that looks like it might contain something called stromatolites.
On Earth, we had bacteria, and not just individual bacteria, but bacteria that formed colonies, which created rocks known as stromatolites. These are, you might call, the bacterial equivalent of coral reefs, where tiny organisms build up something big. This would be a logical thing to look for on Mars.
Stromatolites on Earth provide the kind of evidence that we would expect to see on Mars. Not in that exact form, but it's the basic idea. Stromatolites were sort of mats of algae and then silicate-like material that built up and formed macroscopic structures which were then preserved. If something like that was going on Mars, that would provide an easy way of determining that life did indeed exist there.
Many science fiction films are based on the idea that we'll find evidence of advanced civilizations on Mars. Mars has no cities or grand structures. But astronauts may yet find evidence of life on Mars. Even if it's only fossils of bacteria. With the rock samples loaded in, the rover tries to head off, but goes nowhere. One wheel is stuck. The astronauts cannot free it.
Sand is sort of the death trap of Mars. And I wouldn't be surprised if, in future expeditions, we end up losing some crews that are on these long pressurized rover traverses to sand traps.
They calculate the remaining distance to the ERV. Could they walk to safety? A spacesuit's full tank of air will only last 12 hours. It would take 30 hours of continuous walking.
On the Earth, you can get stuck when you are doing all-terraining in sandy areas, but of course, on the Earth, you can just step outside the vehicle and breathe. On Mars, you won't have that option. So if your vehicle is stuck and there's no way to get it out of its predicament, you're going to watch yourself die.
In our scenario of what might go wrong for the first human mission to Mars, the astronauts' rover is trapped in the Martian sand. The Earth return vehicle is 100 miles away. Are the astronauts facing certain death? Or can they save themselves once again with pre-industrial technology?
So let's say the crew was stranded and they need to get at least one person a considerable distance to secure another vehicle and come back and rescue the rest. Could they do this with balloons? It's just possible.
Engineers on Earth run tests to see if a balloon could carry at least one astronaut over the desert to the ERV.
You could do this by stretching a synthetic membrane of some sort around a pocket of the surrounding air, just carbon dioxide. And then you'd have to heat the air inside in order to give it some buoyancy. Now, one way of doing that is having solar heating. Effectively have the membrane absorb solar energy, heat the carbon dioxide inside. It then expands, becomes buoyant, and lifts the balloon up.
Any balloon that you would construct or fabricate on Mars would have to be very large to compensate for the very low density atmosphere.
The Martian atmosphere is very thin. It's less than 1% of Earth's atmospheric pressure at sea level. That means that to get substantial lift, you need an enormous balloon.
A balloon that is 10 meters in radius is probably enough for one astronaut in a spacesuit. Why would a crew on Mars have a balloon that big? They probably wouldn't, but they might have a large number of balloons used for scientific purposes that were smaller than that.
The risky plan is put into action. In a makeshift harness, one astronaut rises into the Martian sky. A mile up, winds blow her towards the ERV at 60 miles an hour.
On Mars, the prevailing winds near the surface blow from west to east, and we want to go from west to east, so that's good for us.
One of the big problems with this scenario is the precision at which you could hope to reach your destination. But if you could then come down within hiking distance of your destination, take some luck, but it's possible.
Mars has only 38% of Earth's gravity. Science fiction movies usually forget that fact and have astronauts operate in normal Hollywood gravity. The truth is, even with the heavy spacesuits, worn during extravehicular activity, hiking on Mars will be easier than on Earth.
Let's say you're a 150-pound person and you put on a 200-pound suit. That's 350 pounds. But then if you only weigh 38% of that, okay, then your weight is maybe 120 pounds with the suit. So you actually have less of a burden in walking with that suit on Mars than you have walking in your stockings on Earth.
The astronaut lands successfully and manages to hike to the ERV and the two-person rover. Everything's in working order.
So one of the astronauts gets into a dune buggy rover, comes back to the pressurized rover, takes one of the astronauts, brings that astronaut to the Earth return vehicle, then goes back and forth a couple more times to get all the astronauts over to safety.
That's the plan. But then a new danger arises. A storm of red dust.
The sun would get dimmer in the sky, and it would continue to build, and you'd see from horizon to horizon this pretty thick, dusty, swirly mass in the atmosphere.
But what causes dust storms on Mars? That's what Lisa Abdel-Fattah of Anaheim, California, emailed Ask the Universe.
Lisa, you might be surprised to learn that dust storms on Mars are actually caused by energy from the sun. The sun heats the dust in the surface of Mars and also the atmosphere, causing it to expand and causing convection currents to occur. And there are differences in pressure between one pocket of air and another. That leads to winds. Then more dust gets kicked up and more heating and more of these pressure differences. So you get these violent dust storms.
The dust on Mars could be very hazardous to astronauts for a number of reasons. Because there's no water on Mars, the individual grains are not smooth and rounded like you would see on a beach here on Earth. They're actually very sharp and jagged. And as that dust gets kicked up as the astronaut's walking or moving, it gets caught on the spacesuit. And over time, due to friction, let's say the astronaut's moving arms or his legs, it begins to eat away at the fabric of the spacesuit. So you could easily get a tear or a rip in the spacesuit, and that would be catastrophic.
Despite the dangers, the astronaut takes the small rover, loaded with extra oxygen, out into the storm. And one by one, she brings her crewmates back to the Earth return vehicle. But just a few feet from safety, the abrasive dust tears a section of the commander's suit, exposing him to the near vacuum of the Martian atmosphere.
If your spacesuit springs a leak, or if it's a violent decompression where your suit is ripped open, you might not have more than a few seconds to remain conscious and see what's going to happen to you.
You would be in a very bad way. It would be not dissimilar to coming up from a very deep dive on the Earth. It would be a very painful experience.
If you have a decompression problem, then it can be very serious and lethal. You will die a horrible death, and very quickly as well.
Unless his crewmates can do something immediately, the commander will be the first human corpse on Mars. In our scenario of the near future, the first explorers on Mars have survived a near-fatal crash and a dangerous trek across a hostile planet. But now, a storm of abrasive dust has torn a hole in the mission commander's spacesuit. It's the one thing the astronauts fear above everything else.
You've got 10 or 12 seconds before you lose consciousness. You'd better exhale right away. Empty your lungs, because otherwise they'll quickly expand and rupture.
12 seconds after his suit tore, the commander is unconscious. His skin is turning blue. His crewmates have less than 90 seconds to get him through the ERV's airlock and administer emergency oxygen before his blood circulation ceases and his organs shut down forever.
After you've lost consciousness, you hope that someone will hook you up to pressurized oxygen within the next minute and a half. If you don't get hooked up, you'll die for sure. If you do get hooked up and you start breathing oxygen again, it turns out that when you come to, there's usually not much permanent damage.
The commander survives with seconds to spare. Despite his injuries, he will make a full recovery. Soon, the crew is back to full strength, working and performing experiments. The exploration of Mars has begun in earnest.
Mars, to me, will challenge all the expeditionary experiences that we've had throughout our history. It will take all the best lessons learned from all past expeditions, the polar ones, the ones through the jungles, the ones through North America. Mars is a super challenging place. It's very unforgiving.
Here on Earth, if things go wrong, we can rely on there being air to breathe and water to drink. On Mars, if something goes wrong, then the situation is automatically much more serious.
But the astronauts have proven that they can adapt to the Martian environment. Like polar explorers, they protect themselves from the frigid temperatures. Like desert explorers, they learn to live with the ever-present dust.
In our own desert station that the Mars Society runs, we brought out a really superb microscope, but it was disabled by dust within a few weeks of its arrival. On the other hand, some much cruder kind of microscopes, similar to the kind that college students use routinely, have proved very robust. In a frontier environment, you don't want to bring a racehorse, you want to bring a mule.
Not everything on Mars is more difficult than on Earth. The surface winds, for instance, are mild, too weak to threaten the astronauts or their instruments.
The Martian atmosphere is only 1% as thick as Earth's atmosphere. And so if you're on the ground and a 60-mile-an-hour wind kicked up, you would only feel the force of a 6-mile-an-hour wind.
We have here an anemometer, or wind gauge, which helps us measure the wind speed. It's a very simple design, really. You've got these cups on top that capture the wind as it blows by and causes the cups to spin. You simply count the number of rotations of the cups, and that gives you the wind speed. It's a very simple design, very much the same as the one that was invented back in the 1800s, except, of course, with this digital readout.
Well, let's see if we can get some wind here. Oh, there we got some. Oh, here comes a gust.
Because the atmosphere is so much less dense and you have far fewer molecules of air sort of blowing on the anemometer, you would need a 20-mile-an-hour wind on Mars to feel what a 2-mile-an-hour wind would feel like on Earth. So you can see the wind that's blowing at that speed is sort of lightly mussing your hair. If you were to have this on Mars, and a similar wind speed that would give you the same sort of effect would be about a 70-mile-an-hour wind. So that's hurricane speed.
The astronauts do more than adapt to Mars. They extract water from the surface and use Martian soil to grow food.
Now, in terms of growing food, the things that can be grown most easily are leafy things like lettuce. At a certain point, you're going to want to grow potatoes, which can create a great deal of starch per square meter of farmland.
A year ago on Mars, 4 humans struggled to survive. Now they are beginning to make a planet bloom. But it's only a beginning. For over a century, movies have perpetuated the idea and the hope that there's intelligent life on Mars. There isn't, yet, but sometime late in this century, 2 people from Earth might give birth to the first Martian, who may be the first of many more. We will be the Martians. But that's the future. For this first mission, time is running short. Earth and Mars are at the right alignment for the journey home. The astronauts look forward to splashing down in the warm waters of the Pacific Ocean. As they head back to that bright blue ball in the star-sprinkled blackness, another streak of light heads the other way. It's the second manned mission, heading for a rendezvous with another pre-positioned ERV.
There's plenty of risks associated with the human Mars mission. But if you look at human history, one thing is clear: nothing great has ever been accomplished without risk. And nothing great has ever been accomplished without courage. If we send humans to Mars in our time, if we establish that little Plymouth Rock settlement on Mars in our time, which is what is within our capability, then 500 years from now, there will be new branches of human civilization on Mars and on many worlds beyond. It's the birth of the future.